Hey guys, it's me, your boy Monkey, back with another video. Today we're playing Minecraft with probably for you a very low FPS. But here we are. This is my first fully functioning Minecraft computer. Um, well, the only thing it doesn't do that I wanted it to do was it can't write to its own hard drive. I have to write into it manually. But that's actually gonna be fixed in the next one because I've already started working on the next one. It's been about a month now, but I was not making videos, so you guys never saw it. So yeah, this thing has a whopping 16 bytes of RAM in here in the system. It has a 912-bit hard drive, which is this giant block here. It's ginormous. The next one is there's so much space that I lost here because this was the first time I made this type of storage, like a non-sequential. Because I used to always make shift registers. This thing has an 8-bit CPU. The clock speed, well, it's not actually not fixed. It just kind of as soon as it completes a task, it sends it through here and it just requests the task from the hard drive. So it's very slow. It's really slow, but it runs. And well, currently some chunks aren't loaded, so I can't actually run a program because I have 3 programs saved in this, 3 very basic programs, but I can boot it up. So I'll show you guys how my Minecraft computer works. I'm not 100% sure this is how the actual professionals do it. I just kind of did what I thought would work. The only thing, before we start, the only thing I have to mention that isn't my design is this this addition circuit. I sadly do not know who made this. I know I got it from another YouTuber who makes a lot of Minecraft computers. I haven't seen him upload recently, but his name was Benny's Cube. He has a few thousand subscribers. But yeah, this is a binary adder which I just stacked on top of itself, and here's the subtractor, so it's one, but it's the same thing but slightly modified. So it subtracts instead using a 2's complement. I think that's the term. It's weird. So if you don't understand it, it's not a problem. Here is the on button. So the on button. So you can see it boots, right? It does the little tune. The thing displays, right? I don't know if it's going to run the entire thing because I know I need to add ticking areas, and I transferred the world to a different device, so I don't know if it saved all of them. I don't know if it still has all the ticking areas. It should, but I don't know. So let's see. When it's finished booting, we should see a signal go through right on this line, right? Let's see. Is it in? I think it unloaded the chunk. Because we should be seeing that square in the middle, which is kind of like the Windows logo type thing. Yeah, it should disappear, but since it didn't because of missed chunks and stuff, I gotta manually do it. But yeah, my friend, here are all the people who helped. So Kagurumi helped building. Bruce Jr. I don't know how you want to say his name in English, but he helped with he's the one who made all the note block things. These are just random note block things. He made a Megalovania machine. And here's the song thing. Well, that's the shutdown, and this is the boot up. And then all my other friends helped with redstone. He helped a lot with redstone. He made this part of the circuit. It's the only part of the circuit that hasn't failed at some point for some reason. I don't know how, but basically every single other part has broken it. Then there's everyone else: Chat, Dirt Monkey Boy, Supernova, Waxen Healer, Xbox Sleep, Galactic. They all helped with this. They all helped building in different ways, or some came in, I explained, and they actually kind of helped figure out problems that I didn't notice. And so yeah, here on YouTube, these are the 3 three YouTubers that really inspired me. Seth Bling really inspired me a long time ago. I don't watch him as much because he doesn't make Minecraft anymore, and I don't play the other types of games he plays now. Mumbo Jumbo, of course. Well, I watched his videos on Redstone for beginners and Redstone for experts. I already did Redstone before it, but when I watched those videos, it really clicked for me. It really changed how I built. Benny's Cube is, of course, the guy who makes the Minecraft computers, where I took the pink circuit right here, and it's the reason this computer exists. Originally, I was just gonna make a CPU, just to try to make one, and well, I kind of just decided to make the whole computer. Oh yeah, forgot about the screen specs, right? This thing has a it's an 8.5 by 6.5, I think. 1, 2, 3, 4, 5, 6. Yeah, 6.5. And I say in a half because there's actually an extra set of half pixels here that blink when I turn them on. So yeah, let's go through the process that the whole computer goes through, right? So when I press the on button, it starts this. This is a T flip-flop, so this light turns on, right? This sends a signal through here, which starts the tune that you hear when it starts up. And then it sends us a pulse through here, which resets the screen in case there was something that was glitched and still on the screen. After that, it sends a pulse through here, which goes to the back here and into here. This sends a signal into the back of the graphical system, which is this giant block behind the screen. And it actually resets part of the screen data and also makes that square display. And also, I don't actually send manual commands through the system like I should, just because, well, this computer is too slow. It would take so much longer to actually boot it up. Then this resets the screen's RAM, some of the screen's RAM. Like that's the data that is that stores which row you're actually editing, because basically the system has two functions to control how you draw. It has one that lets you choose which row you're editing, and the other one just makes you send in data and edit that row. So that's what that does. That basically resets which row is being edited. Then it sends a signal through here, under this loop, and it resets the RAM, right? So it shifts all these pistons up, which unlocks these repeaters like this, and then the signal just goes through and it stops saving. After that, it goes through this whole thing. There's also delays because it would lag the game so bad when I did this. This also removes all the temporary program memory. So basically, this saves at which step in the program the hard drive is. That's what it does. So I basically empty this so that this doesn't happen. That shouldn't be like this, because now it's actually reading data, and that would mess things up. And so yeah, this computer was my first test. It was not very good, but it still shows that I can do much better. Now this goes into here, goes up this, back down in this loop. It goes down here and back into here, and this resets the screen, telling the user that he can input a command. Now, here I'm not going to do anything too complicated, but I want to show. Now, how you enter a command is you put them in this keyboard thing, and it actually sends them straight directly into the CPU. But well, it goes through this to connect to the CPU, but nothing affects it directly. So it goes into here, and then the CPU takes this data, sends it underneath, and if you have the correct ID, so the correct combination, so it's like a combination lock, and if you put in the correct combination, so the right ID, it'll actually activate that function and lock it and let the data go through it. So for example, this is the addition, so it would add the data in the red and orange here that you send it through, and it would add it and then go straight into the RAM, and that's where you would add that's where you would send the RAM data. So the purple lines and the magenta lines, those basically tell the system which piece of RAM to read from or write to. So that's how it works. And then well, you can see the read. So it goes into here and it just connects back into these 8 pins, which are the parameter pins. And so it's the same thing for the graphics system. The graphical system is connected into the CPU, which slows the system down, which won't be the case in the next computer. So it works. It's extremely slow, but it works. I'll actually make a list of all the functions that this system has. I don't know what's usually in a real CPU, but this thing has an add, a subtract, a flip, so it kind of flips both halves of the 8 bits. Then we have the AND gates. I think this is the AND gates, and basically it takes so byte 1 of the first half of the 8 bytes goes with the second byte, which is it's kind of confusing to explain. But basically, if the first byte of the second half and the first byte of the first half are on, it'll send an on. And same thing for the second and third and fourth. So that's how that works. Then there's this. Okay, so this is a shift, so it shifts all the data by 1. And well, the last one just goes to the first. Well, the first goes to the last. It's a bit confusing. Then there's if we go back to the beginning, we have a function that just lets the data go straight through, which can also be used to actually make the CPU pause. If I want to, for example, wait for an input, which I do in one of the programs, but the game lags too much and it's too broken. This is a split, so it only takes half of the 8 bytes, the 8 bits. Sorry. And then there's the OR here, which just takes if one of the 2 bits, like I explained with the AND, well, is on, then it'll just send it through here and into the RAM. Then there's the I think this is NAND, so it's like the AND, but it just reverses the output. And then I think there should be an XOR. Yeah, XOR. So how an XOR works is if one of these is on, it'll send an on, right? If the other one is on right here, so it's like an OR. So if one of them is on, it'll send an on, right? But if both of them are on, it'll turn off. So it has to be that these 2 inputs have to be different for it to send a 1 or an on, however you want to call it. And this is just the execute function. It sends a signal into the hard drive, telling it to run a program. So yeah, I'm gonna actually do a little test. I can't remember all the IDs perfectly, but I know I do have books. I do have a book with all the information. So if we go into where is it? Video commands, pick row, right, side cursor. Let's edit side cursor because that's the one I know works. 10011. So these things all work. It's just that I have to load all the chunks, so it's kind of annoying. Like let's do that, and let's just kind of okay, like that. So that should send in some data. Then we do that. That makes it go through. We should see it go underneath here. Go over here. You can see go. I'm also loading the chunk while I do this. It goes into here onto the side and saves into these little well, save things. And now it allows the redstone to go through and actually, blink the cursor. And if I were to turn all of these on, it'll actually turn on this corner thing. Same thing for here. If all of these are on, it should turn this on, like that. There's nothing that actually individually controls this one. So yeah, that's how that works. So it's basically all for this computer. Let's turn it off, and I'm just gonna reset the keyboard. Next one will be much better. And let's go turn it off. should hear it soon. There it goes. Then, I don't actually know if you guys can hear my game sound. Should send a signal through at some point. Then it resets the screen like you saw. And the system is off. Yeah, I know. It's not resetting the screen for some reason. Gotta check that out. So yeah, this is the first test for a computer. It works. So this was fun. Alright guys, so I kind of forgot to record an outro for this. So here it goes. Thank you guys for watching. Hopefully new videos are on the way. At the moment of this recording, I actually have another video recorded. But yeah. See you guys soon. See ya.